Namaste to all my dear students. How are you? Today I am giving you very interesting lecture about the Wurtz reaction, electrophile and nucleophile, and these are very important for examination. So before discuss about this, at first I am giving some knowledge about the mark distribution in examination. So what is out of 100? So what's it? 25% lab work, and what is the project? Lab work and project, and 75% is theoretical portion. In this respect, so what's it? There are three groups. So group A, multiple choice questions. So what is how many? 11. Generally 11 questions over here. Next one is group B. From this section, so we have to solve 8 questions which carries 5 marks. So how much? 40. Group C, so 3 questions and 1 question carries how much? What's 8 marks. So how much over here? 24. So altogether what do you get? 75%. So out of 100, 25%. So for this is what you say for lab work and project work. 75% is theoretical portion. In this 75%, what do we see over here? From group A, we have to do 11 multiple choice question, 11 marks you can say. 1 question carries 1 mark. Second one is group B. From group B, we have to solve 8 questions, and 1 question carries how much? 5 marks. So how much? 8 5s of what is 40. Third one is group C. So from this section, we have to do 3 questions, and 1 question carries how much? 8. So how much? 24. So altogether, what you get? 75%. So the 11 examination generally not conducted by what you see NEB, Nepal Engineering Board. That is done by performed by college itself. Yes. So I am giving you all the what you see tricks how to solve the questions given in the examination. So you have clear mark distribution in examination. Now next one is very important for you, that is Wurtz reaction. So what we have? Wurtz reaction. Wurtz, WRTZ reaction. That is very important for knowledge, very important for examination viewpoint. Yes. So Wurtz reaction. So what the main principle of this one? Principle of this reaction is to convert lower alkane into higher alkane. So main principle of this reaction is what we have? To convert lower alkane to higher alkane. Facts. The statement given by Wurtz, chemist. So what is the fact? We can say when alkyl halides are heated with sodium metal in presence of dry ether. Always we have to do in presence of dry ether. We get higher alkane with even number of carbon atoms. So what the meaning of even means? 2, 4, 6. That number is known as even. So even number of carbon atoms. So in this case it is useful to prepare or synthesize symmetrical alkane. So in this case we have to remember 2 points over here. So at first we have to know what the principle of this reaction to convert lower alkane to higher alkane. Facts means a statement given by Wurtz reaction. So when alkyl halides are heated with sodium metal in presence of dry ether, we get higher alkane with even number. Always keep in mind. Even means 2, 4, 6. Just even number. And that is also known as symmetrical alkane. Yes. So that is about the statement given by Wurtz. So when you talk about the general reaction, so what we see, Rx means alkyl halide. Yes, alkyl halide when this is treated with sodium metal. So in this case always keep in mind, always just doubling of the R group over here. R means alkyl group. So Na, X, second molecule, that is the first molecule, that is the second molecule, always in presence of dry ether. Yes. So what we see over here? So X come over here, 2 Na atom over here, and 1 X come over the, so what do you see? 2 X means halide. So I'll talk about X, maybe chloride, maybe bromide. So better to say X, maybe chlorine, maybe bromine, maybe iodine. Yes. So what do we get? Product R, just doubling of R over here. And what do we get? 2NaX, sodium halide. That is sodium halide. That is higher alkane. So one term is what you see, alkyl. So you must know what is alkyl. Alkyl means alkyl group. So alkyl means if one hydrogen is less than alkane, general formula is CnH2 plus 2 is known as what you see? Known as alkyl group. So known as alkyl group. It means alkyl group is denoted by R. So always alkyl group is related by what you see, denoted by what you see, R. So what it means? Suppose that is the formula of alkane, CnH2 plus 2. So one hydrogen is less than alkane. So what you see? If carbon is suppose 1. So what we have? 2 into 1 plus 1. So what we get? CH3. Always one bond is always deficient over here. Likewise, C2. 2 into 2 plus 1. So how much? C2H5. That is known as one carbon over here. So what we have? Methyl. 2 carbon over here. Ethyl. So always one bond is vacant over here. And in this vacant bond, so any, what you see, functional group inserted over here. Maybe yes, in this case, halogen. Sometimes maybe alcohol. Sometimes maybe amino group. Sometimes maybe any ether group. So many functional group we have. So you have cleared the general reaction. We have also cleared what is the alkyl group. Also you have cleared how can you define what is the alkyl group. So this is the one hydrogen less than the alkane. So C1H2 plus 1. So what we have? CH3 methyl group. C2H2 into 2 plus 1, how much? C2H5, that is ethyl. Yes, we have cleared what the alkyl group over here. Yes. Now, example is like this. What is say general formula R. Example is like this. CH3, suppose Cl. What the name of this compound? Chloromethane. So when this is treated with sodium, so what we have? Another molecule of CH3. So always just doubling. Dry ether. Heated, what we have? CH3, CH3. How many CH3? 2 CH3. So what we have? CH3, CH3 plus NaCl. So how many? 2. 2 chlorine over here, 2 Na. So what we have? 2 NaCl. And that is also known as C2H6. That is ethane. So what do you see over here? Lower alkane, 1 carbon over here. Well, just doubling. So what we have? 2 carbon. If 2 carbon, what do you get? Like this. C2H5Br. What the name of this compound? Bromoethane. How many carbon? 2 carbon. So when that is reacted with sodium, so what we have? Always 2 molecule. Keep in mind. Same condition, dry ether. So C2H5 when doubling, so what we have? C4H10 plus sodium bromide. So that is butane. So what do you see over here? So always what you see, just doubling of carbon, just doubling of. So in this case, 1 carbon, so what do you get? 2 carbon over here. In this case, 2 carbons, what do you get over? 2 carbon. Also we have to keep in mind, always we have to use the same alkyl group. If this is C2H5, I write C2H5, CH3, Cl, so that is not correct. Yes. So in this case, always there is formation of symmetrical alkane. Another example is like this. CH3, Br, H. So that is 1 position, 2 position, 3 positions. So what do we have? 2 bromo. How many carbon? 1, 2, 3. So what we have? 2 bromopropane. When that is treated with same molecules, what we have? CH3 Br, 2 Na. Condition is same. So what we have? CH3, carbon always must be tetravalent. What the name of this compound? 1, 2, 3, 4. So in which position? 2 and 3 positions. What we write? 2, 3 di methyl, what do you say? Butane. So generally these three examples are asked in examination. So you have to keep in mind. So you have to practice all this. If you practice all this, you will get in the examination. So now we have clear what is Wurtz reaction. So Wurtz reaction, what the principle of this one? To convert lower alkane to higher alkane. So in this case, what we have to use? Alkyl halide is heated with sodium metal, always in presence of dry ether, never what we see moist ether. Yes. So there is a reaction, and what we get? Higher alkane with even number, and we can say symmetrical alkane, we can say. So these three examples are very, very important for you and generally asked in the examination. So I think you have clear what is Wurtz reaction. So any question we have? I think you have no question. I think that is very, very important for examination. Next one is, what do you say? You can say electrophile, or we can say electrophilic reagent, that is always represented by E plus. Always keep in mind. So electrophile. So what it original meaning? Electro means very, very important. Electro means electron. Next one is philic. Philic means to attract. Yeah, better to say to love. To love. Attract means what you see? Love. Yes. So when we talk about this, what you say, electrophile or electrophilic reagent, so that is represented by what you see? E plus. Electro means electron, philic means to attract, or you can say simply to love. It's a very simple word. So now we have to define what are the electrophile. So atom or group of atoms containing positive charge and electron deficient centered molecule, that is also known as Lewis acid. We have heard the name Lewis acid. Lewis acid is always what's the poor in electron. Yes, which attract electron. So that is 34 electron, which attracts electrons are known as electrophilic reagents. So we have clear what we have. So maybe single atom, maybe group of atoms containing positive charge and electron deficient center. What it means, I am giving you the example over here. So what we see, we take very simple example like this. So atom, maybe single atom. So what we see, positive electrophile. So maybe chlorine, what is maybe nitronium ion, we can say or alkylium ion, we can say acylium So single atom or group of atoms. Yes. So maybe single atom, maybe group of atoms. So what do you see? You all have positive charge. Psyllium, sulfonium, etc. So these all are the example of positive electrophile. Why? Because in all cases what we have? Positive charge. Next one is neutral. Neutral electrophile. So electron deficient center. So what we have? Electron deficient centers. What we see? Example is like this. Al, X3, boron, yes, boron halide, trihalide, iron halide. Where X, where you can say X is maybe chlorine, maybe bromine, maybe iodine. So these all are known as electron deficient center. That is also known as Lewis acid. Why they are known as Lewis acid? Why they are known as what is electron deficient center over here? So suppose we take very simple example. So we take any aluminum trihalide. So how much? 2 electron, 2 electron, 2 electron, 2, 4, 2, 6. But according to octet rule, it must have 8 electron. But in this case, how much? 2, 4, 2, 6. What's monovalent bond? Monovalent. Monovalent. So 2, 4, 2, 6. Only 6 electrons. So they are electron deficient center, you can say. So we have clear what are the positive electrophile. Positive electrophile you know easily. Why? Because they have positive charge. So we have problem to know what is the Lewis acid. That is very important point over here. So in this case, no any positive charge, no any negative charge. So when we take this structure, the what is aluminum trihalide, so what we see? 2, 4, 2, 6, 6 electron system. But according to octet rule, it must have 8 electrons. So what we see, what we observe over here? So 2 electrons deficient over here. So these all are the example of Lewis acids. I think we have clear what are the positive electrophile, what are the Lewis acids. Yes. Next one is what to say? Nucleophile, or we can say nucleophilic reagent. It is indicated by Nu, negative charge. Nu means nucleophile, having negative charge, or we can say lone pair of electrons. Nucleophiles. So what is original meaning? Nucleo. Nucleo means nucleus. Philic means what is it? To attract. Or we can say love. Very simple word, love. So how can you define this? What we say? Nucleophile. So electrophile, positive charge, but in this case negative charge. So how can you define? Atom or group of atom having negative charge. In electrophile, positive charge, but nucleophile, what we have? Negative charge and lone pair. Lone pair means non-bonding electron. I will give you some example over here. And lone pair of electron present in central atom of the molecule that is also known as Lewis base. So always keep in mind, Lewis base is always rich in electrons. Rich in electrons. So what we have? Electrons which attract nucleus are known as nucleophilic reagent. So example are like this. Example easy means example you can say. Example are like this. So what's maybe negative charge? Maybe chloride, maybe bromide, maybe fluoride. What do you say? Maybe alkyl negative charge. What do you say? Maybe OH minus, maybe cyanide. What do you say? OH, cyanide, etc. These all are also known as, they are also known as what to say, negative nucleophile. Why? They are also known as negative nucleophile. Why? Because in these nuclei what we have, in each case we can say negative charge. So they are known as negative nucleophile. Yes. Next one is neutral. Neutral nucleophile. So what we have? Suppose when you talk about the water, 2 lone pair over here. So how many electron in oxygen atom? 6 electrons. Out of 6 electrons, 2 are involved with monovalent bond. And what the remaining one? That 2 electrons are known as, that is known as lone pair of electron. That is also known as non-bonding electron. Like this, ammonia, ammonia, one lone pair over here. Like this, ether, what is it? 2 lone pair over here. Suppose when you talk about what to say, alcohol, what to say, etc. That is ether, that is, so all are the example of what to say, neutral nucleophile. Why? Because in this case there is no any charge over here, no positive, no negative. So what we have? They are the example, these are the example of what to see, neutral, what to see, phile, neutral nucleophile. So how questions are asked in examination? So we have already studied about the what to see, Wurtz reaction. So generally asking examination, what do you mean by Wurtz reaction? Give suitable example. So in this case, what we have to do? At first, we have to write the what to say statement given by the Wurtz. Yes. Then we have to give 1 or 2 example over here. So generally ask you 5 marks. Sometimes maybe ask you in 2 marks. That's very, very important. Next one is define nucleophile and electrophile with suitable example. Yes. So we have to define nucleophile and we have to give the suitable example over here. Likewise, we have to define electrophile, then we have to give the suitable examples. Yes. Sometimes ask you what type of question? Classify the following nucleophile and electrophile. Classify the following nucleophile and electrophile given here. Likewise, Cl plus, what to say, OH minus, what to say, H2O, aluminum halide, you can write any, aluminum halide, boron, tribromide, ferric tribromide, what to say, cyanide, next one is I plus, so NH3, etc. So we have given the what to see all the nucleophile and electrophile. Now we have to classify all these. So how can we classify? So like this. How we have to write in examination. So make a table over here. So that is nucleophile. You know, Nu, negative charge. Next one is electrophile, E plus. So if it has negative and positive charge, we have never problem. So what is the nucleophile negative charge? What we have? OH. Now, what is the next one is electron rich. So what you see? H2O. Next one is boron. So that is the Lewis acid, cyanide. Next one is what do you say? NH3, ammonia. These all are nucleophile. So generally we have to troublesome neutral, maybe nucleophile and maybe neutral electrophiles. We have to keep in mind. Electrophile over here, Cl plus, what to say, Al, Cl3, Lewis acid, boron tribromide, what to say, ferric tribromide, what is I plus. Yes, so these all are the example of electrophile. If you write all this, you get the full mark. Yes, so mark are very, very, bazar mein so many marks in the markets. Now we have to collect all these market. What is the mark from the market you can. Yes, so that is about what you see Wurtz reaction, electrophile and nucleophile. So what type of questions are asked in the examination? I have already given you. Next one is classify first degree, second degree, third degree and fourth degree carbon in the given compound. Given compound is CH3, 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 CH2, CH3, CH3H. So in this compound we have to find what to see how many first degree carbon, second degree carbon, third degree carbon and fourth degree carbon. So look at over here. Look at over here. So first one is what to see first degree, or we can say primary primary carbon. So how can you define primary? So always we have to keep in mind all the side of the methyl group. So this one what is primary, 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 primary. All the side of the chain are primary generally. So what we have? If the central atom, if the central atom of the carbon is attached with single carbon atom, or we can say 3 hydrogen atoms. 3 hydrogen atoms are known as first degree carbon. Yes. So what we see over here? So we have to see. So first degree carbon in this case is how much? So 1, 2, 3, 4, 5. First degree, first degree, first degree, first degree. All the side of the carbon, that is known as prime. So this carbon is attached with only single carbon. That is attached with one single carbon. Yes. So how many? 1, 2, 3, 4, 5. So how much? 5. So generally asked in examination in 2 marks. First degree carbon. Second degree carbon, how much? So what do you see? Second degree, that is also known as secondary carbon. If the central carbon is attached with, if central carbon is attached with 2 carbon atoms, so we can say better 2 hydrogen atoms are known as, what is this? Secondary carbon. So in this case, secondary carbon is how much? So that is secondary. This carbon is attached with this carbon and that carbon, and 2 hydrogen atom over here. So that is second degree. Why? Because the central carbon is attached with 2 carbon. We can say better to say 2 hydrogen atom. That is known as secondary. So how much? In this case, 1. Like this, third degree, I can say tertiary carbon. If central carbon is attached with 3 carbon atoms, or we can say one hydrogen atom is known as third degree carbon. So in this case, how much? So if this carbon, when we talk about this carbon, so that carbon is attached with 1, 2, 3. Now we can say 1 hydrogen. This carbon is attached with 1 carbon, 2 carbon, 3 carbon. That is 3. So in this case, third degree carbon is 1. Now, what we have to see? 4 degree. What is it? 4 degree? Yeah, we can say quaternary. So, and define over here. If central carbon atom atom is attached with 4 carbon atoms. Carbon atoms are known as 4-digit carbon. So in this case, this central carbon is attached to 1, 2, 3, 4. That is 4-digit carbon. So in this case, 4-digit carbon is 1. If you write all this, so you will get 2 marks. It's very simple. Yes, so we are now, I think we have clear what are the first degree, second degree, third degree and 4-digit carbon in the given organic compound. You can find out. I have already give you the definition as well as example. Yes. So thank you all for hearing this video. Now I will try to next slide or next video, that is homologous series. So next day I will describe about the homologous series. That's very, very important. Yes, today is okay.